We are going to look at sections 3.1, graphing polynomial functions today. So if you want to follow along in your textbook, this is lesson 3.1, graph polynomial functions. All right, to graph a polynomial function is going to be very similar to some of the things we looked at in the last unit where we were talking about transformations of quadratics. And now we're just looking at polynomials. So let's look at the parent cubic function. And the parent cubic function is f of x equals x cubed. Look at these graphs to see how changes of the parent function create different transformations of the parent function. So here's a sketch of a cubic function, a parent cubic function. So this is something you could kind of commit to memory. It's just kind of knowing what that general shape looks like and that it has this shape, the end behavior, and that it goes through the point 0, 0. All right, so it says complete the description of the transformation. So you can see this is the same general shape, but now it goes through 0, 1 instead of 0, 0. So you can see that this is a transformation up 1. So it's been moved up 1 unit. All right, complete the description below. All right, it says g of x equals 1/4 x cubed. So you can see how it's kind of wider now, how it expands out. It doesn't go quite as steep up as it did before. And that's because it has vertical compression of a factor of 1/4. And then the next one, you can see it's even narrower, so it's kind of skinnier. It kind of is more compressed in towards the y-axis. And that's because this is 4x cubed, so it's a vertical stretch by 4. And again, they're all kind of the general shape. They're all cubic functions, so that's what creates that general shape, but they're just transformations of that. All right, so this one you can see instead of going through 0, 0, it's been shifted over and it goes through 1, 0. So this one has a translation to the right. So that means it's been translated right by 1 unit. All right, the general form of a cubic function that shows all the parameters that can possibly transform the parent function is f of x equals a times 1 over b times x minus h cubed plus k. And again, if you remember in the last section, you had a couple problems where you had to find a, b, h, and k. So parameters a and b involve multiplication and cause stretches and compressions. Your parameters h and k involve addition and cause translations right, left, up, or down. So we're going to complete the description of each transformation. Identify the values a, b, h, and k. So it says consider the function g of x equals 4x cubed minus 2. This can be rewritten in the general form of g of x equals 4, parentheses, 1, since there's no b, it's assumed to be a 1, and then x minus 0, since there's not an h, we can add a 0 there, cubed minus 2. So these two functions are the same thing. They've just rewritten this one in the general form, okay? But if you simplify this, it becomes this right here. All right, so it says a is the number in front of our x cubed, so a is 4. And then b is the number here in front of your x. So b is 1. And that means there will be no horizontal stretch or compression. It's just the same as the parent function. Since h is the number here, and it's not in this one because 0 is just kind of a placeholder, but that would be 0. And k is the number here on the end. So that would be your negative 2. And that means there would be a vertical translation down by 2 units. All right, it says compare the graphs of f of x equals x cubed, that's your parent function, and g of x equals 4 x cubed minus 2 to confirm the translations. So right here we can see this dark line is our parent function. It goes through 0, 0. That's our f of x equals x cubed. And then the translation, 4x cubed minus 2, you can see this one's been shifted down to, and your a is 4. All right, so the graph of a quartic parent function, okay, quartic means 4, so this one's going to have a power of 4. A quartic parent function has a turning point at 0, 0 and points 1, 1 on the graph of the function lies to the left of the turning point and 1, 1 lies to the right. These reference points can be used to help determine the equation of a transformed quartic function. All right, so again you can see the parent function is f of x equals x to the 4th power. So x to the 4th power, here's your 0, 0, negative 1, 1, and 1, 1. So a should be your f of x. That's your parent function. And then this gray line is going to be your g of x. So it's got an a of 2, b is 1, h is 1, and k is 2. So let's see what that looks like. All right, it says find the general form of the transformed function. So it says where do these points move to? So I can see that negative 1, 1 from my parent function, negative 1, 1 will go here, the 0, 0 will go here, and the 1, 1 will go to this point. So all we're doing is seeing which point this maps to. So negative 1, 1 will map to 0, 4. 0, 0 maps to 1, 2. And 1, 1 maps to 2, 4. All right, and it says transform functions is g of x equals a, parentheses, x minus h to the 4th power plus k. X is transformed by adding h. Y is transformed by multiplying by a and adding k. Knowing this, you can figure out h by looking at the related turning points and your reference points. All right, it says use the x and y value to help you determine h and k. All right, so we've already determined h and k by looking at the graph, but they want us to look at it using the points. So 0 plus h equals 1. So again, if you go back up here, you can see that h is your horizontal shift, k is your vertical shift. So we moved over 1, but that started at your 0. H is going to be 1. And then 0 times a plus k equals 4. And then if you solve that, k should be 2. All right, so we went from 0 to 2, and we went from 0 to 1. So we went from 0 to 1, and then we went from 0 to 2. So our k here should be 2. All right, to find a, use one of the other reference points and the value you know for k. All right, so we just found k equals 2, okay? So they want us to use that information here. Remember that y is transformed by multiplying by a and adding k. All right, so negative 1, 1 maps to 0, 4. So 1 times a plus k equals 4. Okay, so right here, our y value, okay, we're looking at our y value, and that's going to go to 4. Substitute 2 for k, 1a plus 2 equals 4. So they just want us to substitute this 2 in the formula. So a equals 2, because I would subtract 2 from both sides. 4 minus 2 is 2. And then substitute the value of a, k, and h into the general formula. Alright, so if you look right up here, we already found k is 2. And we found a is 2. And h is 1. So right here, h is 1, k is 2, and a is 2. So y equals a, parentheses, since a is 2, it's one of these. All of these have -1. We know it's a quartic function, so it has to be one of the last two. And then if we look back up, we can see that k is 2 as well. Alright, so what we did was just use the information that we had to find the same function that we already knew that was the information that was given. So if you look at this function here, g of x equals 2 times x minus 1 to the 4th power plus 2. If you go back up here and look at the graph, g of x equals 2 times x minus 1 to the 4th power plus 2. So they just wanted to walk you through the steps to kind of see where those numbers a, h, and k come from. All right, so a little bit about graphing polynomials. If you have any questions, let me know.